Seahawks. Welcome to 1.5's review video for the guided notes. It's adding in radicals and rational expressions. So after you finish doing these guided notes, make sure you check off on the front checklist that you've completed the guided notes on the front of the packet. So there's a couple of rules with exponents and radicals. You cannot combine them unless they have the same radicand, which is the number underneath, and the same index, which is that little number in the front. So if they match, then you can combine them. And we're going to go into detail about that in the next couple slides. And also, you can only combine rational exponents with the same base and the same exponent. So like, for example, x squared plus x squared, the x's both match as the base, and the 2 both matches for the exponents. So you can add those together to get 2x squared because there's 2 of them. So 1 plus 1 is 2x squared. All right, I'm going to show you in details what that looks like in the next page. So first we have a question that asks us to make it into radical form. So you need to change the 8 to the 1/2 power into a radical. Remember, it's exponent over index. So that 2 is going to go to the front and the 1 is going to stay on the 8. So that turns into the square root of 8. Because remember, if there's a 2 here, that's just the square root of that number. So the 2 is multiplied in the front times the square root of 8. Same thing over here, but it's 7 this time because we have 7 in front. So 7 times the square root of 8. And because the square root of 8's both match, you just add the front numbers, and that gives you 9 square root of 8. Moving on. So then you're going to look at here too. The index matches with this one, the 3's, and the 10 is the radicand, matches with this one. So when you're trying to add them together, you can put a 1 in front of this one because it doesn't have a number, and just add the front numbers. So 6 plus 1 is 7, so you get 7 cube root of 10. Next one, same thing, radical form. What you want to look at is you want to see if you can make the bigger cube root into the smaller one. So do you see how this is a 2? So we're going to try to get this into 2 and then something else. So the first thing you do is you're going to divide that 54 by 2 because we want to have 2 left over. So that's 2 and 27. And then you're just going to put cube root of each of those over the top. So cube root of 27 times the cube root of 2 because they came from underneath the cube root. So you got to put that back on. So now we have the cube root of 2 that matches on this side. So you have to worry about this cube root of 27. But let's bring down the minus the cube root of 2 so that we have everything together. And then the cube root of 27 is the same thing as the square root of a number. So the square root of a number is the number times itself twice. So like the square root of 4 would be 2 times 2, or just 2 because the 2 is the square root of 4. So 27 is, there's an index of 3, which is telling you there's 3 numbers that are multiplied by itself, and it's the same number. So what number times itself 3 times would give you 27? Well, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, so it has to be 3. So 3 is what that turns into. Then you have times cube root of 2 minus the cube root of 2. So you're going to combine these two together. So you have the 3 times the cube root of 2 just turns into 3 cube root of 2 minus the 1 cube root of 2 up here. So 3 minus 1 gives you 2 cube root of 2, and you're done. So just remember what number times itself 3 times. If this was a 4, then it would be the number times itself 4 times. So this tells you how many times it has to multiply by itself. So 3 times 3 times 3 is your 27. All right, moving to the next one. So same thing, we're going to try to break it down so that they match somehow. So first thing you're probably going to want to do is divide by 2 because I know that 25, 2 times 25, 25 is a perfect square. So getting 25 means I can take the square root of that 25 and just get 5. So when we bring it up to the front, that leaves the square root left over. So 5 times the square root of 2 gives us 5 square root of 2. Then we can't do anything with the 10, so we're just bringing it down, plus the square root of 10. Because 2 and 5 are not perfect squares, you can't take the square root of 2 and get an even number, and you can't take the square root of 5 and get a whole number. So now, looking at 18, I know that another perfect square is 9. 2 times 9 gives us 18, and the square root of 9 is 3. So if we break that apart, we can put 3 down and bring down our square root of 2. So now I'm just going to multiply that 3 into the square root of 2 at the end because that's what it's attached to. And then bring down our 10. And now you can add these two or subtract these two together because they have a common radicand. So this is a 3 and this is a 5. So 5 minus 3 is 2 square root of 2. And then you're just going to bring down your 10 and that's your answer. Because the 10 can't combine with anything, it just tags along for the answer because you can't do anything with it. Next one, same thing, radical form. So we're going to switch them all to radicals. So we have the cube root of 2, cube root of 8, and the cube root of 54. So we've done the cube root of 54 before. I just rhymed, I didn't mean to. So cube root of 3, or cube root of 2 you can't do anything with, but the cube root of 8 you can. 2 times 4, and 4 is your perfect square. So you're going to have 2 times 4 is, actually, sorry, I misspoke. Cube root of 8 is actually 2, because 2 times 2 times 2 is 8. So taking that number times itself 3 times gives us 8. So the cube root of 8 is 2. And then we've done the 54 one before. That's just breaking it up with cube root of 27 times the cube root of 2. So notice how we have some matches here. We also can simplify this cube root of 27 if you go back to the couple questions ago. Remember that would be 3. 3 times 3 times 3 is 27. So that changes to 3. And then we multiply it with the cube root of 2 that's on the end that it's multiplying with. And then we're going to bring down our cube root of 2 and bring down our 2. So now we're all on the same line. So we have some matches here. We have the 3 cube root of 2 and the cube root of 2 over here. So we can add those together. 1 plus 3 gives us 4 cube root of 2. And the 2 cannot combine with anything because it doesn't match. It's not like terms. So you just tag it along at the end. And whatever sign is in the front of the number is the sign that goes to here. So we combined the 3 with the 1 and got the 4 cube root of 2. And then plus 2 at the end. Okay, next one, radical form again. So we got a few things going on. If you notice, this is the first problem that we've ever had an exponent underneath the radical sign. So this exponent is actually part of the radicand. So it's going to be a little bit tricky, but if you remember, we can break this up into 2 different problems because we can add those 2 together. I'm going to show you what I mean by that. So first thing you're going to do is break this 54 apart. So we have 27 and we have 2. So z cube root of 27 times the cube root of 2. And then the cube root of z squared, because that's the part to the right of the 54. Then we're going to break down this left-hand side. So we have 12 cube root of 2 and the cube root of z squared times the cube root of z to the third. So this is where you're breaking it apart. Remember when we did it in the classwork and in the bell work and in your homework, you had these 2 together and you would just add the exponents and get z to the 5th power. So now you can go backwards and break it up because we know we need a z squared. So breaking it up into z squared gives us something that we can combine with later on. So these 2 will be able to combine later on because we broke it up. So what you're going to do next is you're going to 12 cube root of 2, and then we have the 2z squared because there is the cube root of z is z, and this should not be z squared, 2z squared. Oh, sorry. They multiply these 2 together. So the 12 cube root of 2 times the cube root of z squared gives you 2z squared. So 2 times z squared is where this came from. And then the cube root of z to the 3rd power. So anytime you have an exponent underneath and it matches the radicand, it's just this letter or number that's here. So that's z to the 3rd power, which is z times z times z. And if you take the cube root of that, that's just z left over. So we're going to multiply it to the front. I don't know if you saw what happened. Look next to the 12. So right now there's nothing next to the 12, and because we're multiplying that, we're going to put the z there. So we took the z out of this. That took the cube root of z to the 3rd power, which is just z. We multiplied it with the other 2, and z goes right here because it's on the outside of the radical. Then we have minus z cube root of 2z squared. So same thing again. We have the 2 times the z squared gave you this. Z times this gave you z cube root of 2z. And remember, if we take the cube root of 27, that turns into just 3. So everything's being multiplied together. So you multiply the 3 from here, the z from here, and then 2 times the z squared goes underneath. So the reason why there's no radical here is because once you take the cube root of 27, that turns into the 3 that you pulled out. So now if you take a look, z index of 3, 2z squared matches z index of 3, 2z squared. So you just are going to subtract the front numbers. So you have 12 minus 3, which is 9. So 9z cube root of 2z squared. I know that one was kind of confusing, so if you want to replay it, go ahead. We'll go over more in detail in class as well, but you might want to replay this one. All right, and then we're going to find all of the ones that are equivalent to 3 square root of 2. So we have to solve each of them and simplify them to make sure that they're not 3 square root of 2. So first thing is, if you have it to the 1/2, we make the index 2 and the exponent 1, which just turns it into the square root of 3. Then same thing for the 2 would be plus the square root of 2. So those two cannot combine because they don't have the same radicand. So 3 and 2 are not the same number. You can't combine those. So it would be a no. That does not match 3 square root of 2. Next one, same thing, square root of 8 plus the square root of 2. You can break apart 8 into 2 and 4, and then the other 2's there. And then you can take the square root of that 4. Square root of 4 is 2. And you multiply it with the 2 square root of 2 here, gives you 2 square root of 2. Then you're going to add it with that square root of 2 that's left over, which 2 plus the 1 that's right here will give you 3 square root of 2. So that's our first one that matches. We're trying to match 3 square root of 2, and this one equals that one. Next one, we have 3 times 2 raised to the 1/2, so we're going to switch 2 to the 1/2 to the square root of 2. And if we're multiplying the square root of 2 times 3, that turns into our 3 square root of 2 that we're trying to match. So yes, that's also an option. Next one, break apart 18. We already know that 2 times 9 is what it breaks apart to from the other problems that we did before. So take the square root of 9, which is 3, and multiply it with your square root of 2 that's left over, and that gives you 3 square root of 2. So that one works as well. Next one, we've got 2 and 9 again because that's an 18 underneath. So when you take the 2 times the square root of 2 times the square root of 9, you're going to break apart that 9 and do the square root of 9 of it. So that turns into 3. So the square root of 2 square root of 2 plus 3 cannot combine because those two are not like terms. The 3 does not have a square root of 2 next to it, and this 2 has this extra square root of 2. So those two cannot combine. So this is the final answer for this one, which means it is not a match. Then the last one, we can break apart 8 into 2 and 4, and then the square root of 2 tags along. So take the square root of 4, that turns into 2, multiply it with the 2 that's in front, and you get 2 square root of 2. And then you're going to add your square root of 2 that's left over here, the tag along. So 1 square root of 2 plus 2 square root of 2, 1 plus 2 is 3 square root of 2. So that is also a match. So there's 4 matches out of this one. All right, last one, find the perimeter of the following figure. So perimeter means that we are adding up the outside edges. If you've never had a problem at PE where you didn't dress out and you had to walk around the track, you're walking around the outside perimeter of that track. So every step you take is the number of steps you're taking in total that you're adding together. So we're going to add 3 square root of 20 plus 3 square root of 125 plus 4 square root of 80 plus square root of 5. So if we write that down, you can break the square root of 20 into 4 times 5. Then we have the 4 square root of 80 plus square root of 5 plus our 3 square root of 125. So this is right here, and this one's over here. And then we just started breaking this one apart. So we can take the square root of 4, which is 2, and we're going to multiply it with the 3 that's out front. And then you're going to take this and break apart 80. So 4 times 5 is 20, times 4 is your 80. I wanted to use 4s because 4s are perfect squares. So if we take the 2 out of this one, take the 2 out of this one, we would multiply it with the 4 in the front, and I'm going to do that in this third line. Then we're going to bring down our 5, and the 3 squared of 125, you can break that apart into 25 and 5 because 25 is your perfect square. So now we're going to take a look at what that looks like. So we combined 3 times 2 and got 6. 4 just comes down. You can't do anything with it. Then you're multiplying it with the 2. After you take the square root of 4, it turns into 2. After you take this square root of 4, it turns into 2. And then you're going to bring down your 5, square root of 5. Then you have plus 3 square root of 25 and 5. So square root of 25 is 5. Right here. And you multiply it with the one that's on front. So 3 times 5. And then you have a square root of 5 left over that you can't take out. And then we just dropped our square root of 5 down that we didn't use. The reason why this square root of 5 is here is because we took the square root of 2, we took our square root of 4 and got 2, we took the square root of 4 and got 2, but you can't take the square root of 5, so then that just stays there. And these are multiplying with that. So that's 4 times 2 times 2 times 2 times 5, or the square root of 5. Then drop that one down, then drop that one down, took the square root of 25, turned it into 5, and then just drop this one down. It's still under the radical, so that square root of 5 is right here. So now we're going to combine these, and you get 4 times 2, which is 8. 8 times 2 is 16. 16 plus the 1 that's here, because this is 16 square root of 5, plus the 1 square root of 5 turns into 17 square root of 5. Then we just have 3 times 5, which is 15 square root of 5. And now they all have matching radicands. So we just add the front numbers. 6 plus 17 is 23. 23 plus 15 is your 38 square root of 5. And that is all. Go Seahawks.